This video will cover beginner questions part 2 regarding the topic of trigonometric integrals. Case 1. This is what case 1 explains. Question 1. If the power of secant is even, then save secant square for du. So we can rewrite as integral of tangent x times secant squared x dx. Then this part for du. Then means u equals tangent x. Then derive on each side. Du equals secant squared x, then dx. Then back to the original. Integral of tangent x is u. Du is secant squared x dx. Then integrate u squared over 2 plus c. U was tangent x. Then tangent squared x over 2 plus c. The same goes for question 2. We already know that secant squared x dx is du. So the power of tangent doesn't matter. We can just use u and du we already found in question 1. So integral of tangent to the power of 4x, then secant squared x dx. Then this part is du. Then tangent is u. So u to the power of 4 du. Then integrate u to the power of 5 over 5 plus c. Then u was tangent x. Then tangent to the power of 5 x over 5 plus c. However, if the power of secant is even and greater than 2, then we need to save secant squared x to make du. Now, let's see how it is used in the problem. Question 3. If the power of secant is even and greater than 2, then we need to save secant squared x for du. So, the integral of secant squared x times secant squared x, then keep tangent squared x, then dx, then this part save for du. Use the trigonometric identity. Secant squared x equals 1 plus tangent squared x. If you don't remember this formula, start with sine squared plus cosine squared equals 1. Then divide by cosine squared on each side. Then sine over cosine is tangent. So tangent squared x plus 1 equals 1 over cosine the secant. Then secant squared x. Back to the original. The integral of secant squared x is 1 plus tangent squared x times tangent squared x, then secant squared x dx. Now use u substitution. Let u equal tangent x, then derive on each side. Du equals secant squared x dx. Then integral of 1 plus tangent is u, then u squared times u squared, then du. Expand u squared plus u to the power of 4, then du, and integrate u cubed over 3 plus u to the power of 5 over 5 plus c. Then u was tangent x, then tangent cubed x over 3 plus tangent to the power of 5 x over 5 plus c. Case 2. Question 4. Case 1 cannot be used because the power of secant is odd. the power of tangent is odd. So we save a factor of secant x tangent x for du. We can rewrite as the integral of secant squared x times secant x tangent squared x then tangent x dx. This for du. Use the trig identity tangent squared x equals secant squared x minus 1, or we can start sine squared plus cosine squared equals 1, then divide by cosine squared on each side, then sine of cosine is tangent squared x plus 1 equals 1 over cosine is secant squared x, then tangent squared x equals secant squared of x minus 1. Back to the original integral of secant squared x times tangent squared x is secant squared x minus 1, then secant x tangent x dx. Now use u substitution. Let u equal secant x, then derive on each side. Du equals secant x tangent x dx equals integral of u squared times u squared minus 1. This part is du. Then expand u to the power of 4 minus u squared du. Then integrate u to the power of 5 over 5 minus u cubed over 3 plus c equals u was secant x, then secant to the power of 5 x over 5 minus secant cubed x over 3 plus c. Case 3. This is what case 3 explains. Question 5. If there is only tangent squared x, using the trigonometric identity, tangent squared x equals secant squared x minus 1. So we can rewrite as integral of tangent squared x is secant squared x minus 1 dx equals integrate secant squared x is tangent x minus x plus c. This is the last one, question 6. Because there are no secant factors and the power of tangent is even, we save tangent squared x, so we can rewrite as the integral of tangent squared x times tangent squared x dx equals integral of tangent squared x times, use the trigonometric identity, we can rewrite as secant squared x minus 1 dx. Then expand the first one, tangent squared x secant squared x minus tangent squared x dx. Then rewrite as two integrals, integral of tangent squared x secant squared x dx minus integral of tangent squared x dx. The first one uses u substitution because the power of secant is even. So let u equal tangent x, then derive on each side. Du equals secant squared x dx integral of u squared then du. The second one, that's question 5 that we just integrated. So use the trig identity. Tangent squared x is secant squared x minus 1 dx equals u cubed over 3 minus integrate secant squared x is tangent x, then x plus c. Final answer is u was tangent x, tangent cubed x over 3 expand minus tangent x plus x plus c. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.